That's my shot across the bow.
Loving it. Loving it. Hello and welcome to the Hackaday Podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 302, Scroll Wheels, Ball Screws, and a New Year for USB-C. Happy 2025!
Yay!
I was just off at Chaos Communication Camp. I've been writing up a bunch of the talks I saw there, but I have a deeper feature article brewing up as we speak. I should be able to get that out by next week. How was your vacation, Al?
Well, we kept Hackaday running. We had a lot of good stuff, and it was easy to prepare for the podcast because we skipped a few podcasts, so there was a lot to pick from. In fact, too much to pick from.
Yeah, for sure. In the news this week, we have the European Union's mandate of USB charging on all portable electronic devices has finally passed. And this was a threat to require USB-C as the default charging port on all phones and other small electronics devices. And it looks like it's gone in force. Of course, it's only for the European Union, but this is how we got USB Micro as the default charger form factor before. Remember the old days when we had like Nokia phones with those strange like multi-prong chargers in them and everybody had their own charger and they cost an arm and a tentacle? Well, the standardization on USB solved that, and it looks like it's going to be USB-C from here on out.
Well, I'm encouraged they were able to come up with something that's already in the market, because usually when everybody says, oh, we need to do something in common, they come up with some third thing that doesn't satisfy anybody, right? And so this is at least satisfies some of us to have USB-C.
Right? There's a million dumb things they could have picked, and yet they picked something that's, I know it doesn't make Apple happy because they love selling their proprietary chargers, but I think it makes everyone else happy.
It will sure make cable management at my house a little easier since we have both.
If they could only get rid of my old phones that still use the old USB Micro, I would be a happy camper.
You've got an old laptop and an old phone, Elliot. When are you going to modernize?
Oh, dude, it's time for me to modernize my laptop very soon.
I agree. Having seen your laptop, I can wholeheartedly agree with you. So.
It's an old X220, ThinkPad X220, and I don't think the chargers are made for it anymore. I don't know.
Plus the punch card reader is so loud, Elliot.
The problem is it supports USB 3 and it works just fine. The batteries are removable and replaceable. So for $35, I can get a battery that'll last me for another 4 years. I use it mostly when I'm traveling and mostly when I'm going to places where I wouldn't bring a good computer. And it's picked up some bad dust, and the F key is really hard to type now. It works about half the time.
Makes it harder to type those angry emails, right?
Yeah, totally.
I'll let you do the math on that one. I'm not going to go any further.
All right, well, shall we head on off to What's That Sound?
Oh, yes. The first What's That Sound of the year, right?
It is. This
is a journey into sound.
What's that sound?
What's that sound?
This week is a Reveal the Answers week. We had people before Christmas, actually, guess what the sound was and give us their best guess. And now it is time to roll the dice and see who among the correct answers gets a Hackaday Podcast T-shirt.
Well, how many correct entries did you have?
Let's go find out. I'm going to parse the website right now. Not many. Oh, my God. Let's see. Uh-oh. Oh, this is no good.
Oh, no.
12 answers, none of them correct. That's going to make it easy.
Well, then I think you just randomly pick one of the 12. There you go. That's the...
Oh, that'd be nice. Okay, that'd be the nice thing to do.
That's the escape hatch. If you don't get it right and nobody else did either, then you got a shot.
That's mighty nice of you. I think that's what we're going to do then. Okay, cool. But first, Al, do you want to take a listen to the sound and see what we get?
Sure. That's not the loneliest whale call, is it? I don't know. If you don't know the story about the loneliest whale call, look that up and be sad for a few hours. So
I don't.
We'll talk about that later.
Yeah, well, you are not alone. A lot of people have picked whale sounds on this one.
Too many Star Trek fans.
That's not it, though. It's not it. In fact, it's significantly more pedestrian than that. It's from a video. Actually, I'm going to have to write this up for next week of a bunch of ultrasonic recording experiments. And this is actually a regular old blackbird recorded at 192 kilohertz and then slowed back down, slowed like
Really?
way down to normal speed.
Wow.
That's a bird. And actually, at the end, you could totally hear it. The last little bit sounds particularly birdy to me once you know it is, and once you know it's a bird a few octaves down.
Well, honestly, I did think it was something slowed down, but it almost sounded like a child or something, but I didn't know how to put that into a good phrasing. So, yeah.
I'll write the video up for next week. He does all sorts of other things like dropping a toothpick and slowing it way down, and it's absolutely fantastic. It sounds like a huge piece of lumber being
funny.
thrown on the ground. All the usual things like washers and springs. It's really fantastic.
Well, that was the old movie trick, right? As you film your naval battles in the bathtub and then slow it down so the waves look ponderous and everything, right? So,
Yeah. Yeah, well, it seems to work for sound too. Like everything sounds bigger when it's slowed down, right? Because the resonances must scale up to a larger size system or something. I don't know. I think there's some interesting psychoacoustics to dig into here. Nonetheless, 12 answers, absolutely zero of them are correct. Although a ton of people also guessed whale calls like you did. When in doubt, blue whale, orca call, sound made by some kind of whale. Dry ice in a metal sink or on sheet metal. That's a good one. That's the humans recording whale probe sounds for Star Trek IV, The Voyage Home. Anyway, nobody got it right. Al's suggestion is we just roll for everybody, and I think that sounds fair. Everybody gets an even chance. Thank you all for responding. Let's see what happens. 12 answers, 12-sided die. 11. Congratulations to Henri Bota in phonetic alphabet, which I don't speak. The wrong answer is a dog whining or howling into a vocal effect of some sort. That's a good wrong answer, too. My other guess is pitched up baleen whale calls or something. Yeah. In the whale camp.
everybody liked whales.
Yeah, well, it sounded like whale calls. Who knew that blackbirds slowed down sound like whales? Expect a post on this video next week, and the rest of you tune into the podcast, and we'll see if I can get a sound that people can guess for next week. Oh, actually, I've got a horrible one for next week. I didn't say that out loud. Well, let's head on off to the hacks. I wanted to start off this week with a kind of a simple and interesting exploration of sending data over light. This is Beam Me Up, Simple Free Space Optical Communication. And it's a video by ham radio guy, I guess, W1VLF. Cool call sign. Basically, it's just experimentations with an infrared LED and a photodiode for detection and what you can transmit over this. So he starts off with a simple setup that basically just puts audio into the LED and drives it and then tries to pick it up with the receiver. It works, within a room with a just bog standard LED over kind of 10 feet, 15 feet, the kind of range that, your infrared remote control works over. But then what's fun is he hooks it up to a lens, a big old Fresnel lens to narrow the beam down, and finds out he can go pretty far with that. And again, using IR for the same reason we do it with IR receivers is neat because it's got kind of immunity to all the non-IR sources around us, like fluorescent lights that might mess it up, or, the sunlight, which is kind of constant. So it's actually really cool and just a really simple experiment with this. And it's something that I've always liked to experiment with. I love the idea of taking light and using modulations of light beams as a carrier. And I'm going to do a huge rant and a linked up on that in about a second.
Well, it's interesting to me how old that idea is, right? Because, certainly people used mirrors for signaling for centuries, and even Bell, right, had the photophone, which was basically a mirror
Right.
on a microphone diaphragm. I was just looking up, and I'm not fast enough to find it, but I know in 1970, Forrest Mims in Popular Electronics had a communicator that was light based. And then in the 80s, and that's the one I can't find, and I think it was in 1980, he had one that actually used an LED both as the LED and the sensor, which was, and I think we've written about that before, how they're really the same. But the original one was in November 1970, and it was called the Opticom. So this is a super old idea. And, if you think about it, for a long time it was kind of nichey, but now you send data and audio through light all the time. It's just usually through a fiber optic and not through free space, right? But then again, the NASA beamed cat videos back on a laser the other day, right? So
Right.
maybe the time has come. And I always think this, believe it or not, this is going to be a wild tangent, but I always wonder if things like this are why we can't find intelligent life in the universe. Is everybody's communicating in ways that we aren't really communicating with yet. Especially if you have digital data and you compress it enough, it should sound like noise, right? So you say, oh, here's noise. Well, yep, that's exactly right. A priori proof that there's intelligent life in the universe as we hear noise. So anyway, I just thought it's interesting how old this is and how it keeps coming back, and it's still interesting. So
I know what you mean about it being old, and I think that's exactly it. It's also kind of new because the ability to flash bright LEDs faster and faster gets us a whole bunch more bandwidth on this, right?
sure. Well, and laser diodes too, right? That's a game changer. What would Forrest Mims have done in 1980 with a, cheap laser diode that we have now? So
And it's fun because if you want to do something simple like sending audio, so it's whatever it is, 10 kilohertz, 5 kilohertz over this, or if you want to send just incredibly high data rates, it's actually just kind of a matter of scaling up the equipment you're using. And like you say, of course, many hundreds of gigabits are sent over fiber optic all the time, right? So it's none of this is impossible. What's amazing is how much of it is very hacker friendly. Boy, back in the early 2000s, the Ranja project was using a bunch of LEDs and kind of a 10 megahertz modulation frequency to send data over a kilometer with just a bunch of LEDs and a lens. We also covered more recent takes on the same idea, hacker projects. There was one that got kind of gigabit Ethernet through the air back in 2016. I'll throw the link on that one for you. The secret, of course, is super precise aiming of the sending and receiving beams. And I think one of my favorites on this topic was a talk given by Dominic Spill and Mike Osman at SuperCon. I'll throw the link directly into that video for you. It was called Our Pirates, or maybe it was IR Pirates. But it was all about kind of receiving all the strange and interesting IR data streams that are out there and sending them. And what was fun about this is because both of them have a background in radio stuff, and a lot of this high bandwidth data over light actually uses kind of the same idea, the same kind of modulating a carrier idea as in radio. They actually were able to use GNU radio for most of this work. And instead of plugging in a radio as the front end, they just plugged in a photodiode and had a really good time doing, demodulating all sorts of strange IR signals with the really nice workflow behind GNU radio. That's a really super fun talk because it kind of mixes these two domains up, I guess. I don't know. The carrier frequency on light is so high and so difficult to modulate that we don't really modulate it. But if you turn the light on and off really fast, that gives you a carrier that you can then modulate. And so that's the kind of level on which it's working. It's like meta radio or something.
And, I think new radio doesn't get enough use like that. I mean, we did a series, oh gosh, a long time ago now, so long ago that I'm not finding it, where we started out just doing it for audio, right? There's really no, it says GNU radio, but really it's GNU signals coming into your computer from something, right? And,
Exactly.
And it's usually a radio, but sometimes it's a microphone, or sometimes it's, as you say, a photo detector or any number of things. And it's really just a nice way to visually put Python components together into workflows with different data types. And I think a lot of times people forget about that. I'll stick the link to where we had that in, but man, I've been doing this too long. I can't even remember when the things are that we did years ago, but it's back here somewhere.
General purpose DSP toolkit disguised as a radio project, I guess.
2015, there it is.
Solid. Anyway, if you haven't screwed around with transmitting data over light, it's super easy to get into, and it can be as complicated and as technical as you want it to be.
Well, my first pick for the year, Doom Scroll precisely and wirelessly. And this is Engineer Bo's project. It's an interesting project in of itself, and there were a lot of cute tips, and I want to talk about all of those. But really what got me about this was he had looked at this on a Kickstarter. I think the Kickstarter did not make for some reason. Well, I don't know if they didn't make their funding or they just took the money and didn't produce. So he was like, well, darn it, I really want that. And so he did it himself. And I was like, that's certainly a Hackaday classic story, right? That's the man bites dog of the story of Hackaday. Along the way, what he got out of that was this ultra precise scroll wheel. And honestly, between me and you, I'm okay with my scroll wheel, right? I'm not, it's like the audiophile thing, right? I don't need more than 192 kilohertz, even though there are people who say you do. And this is the same thing. They're talking about like 0.09 degrees of rotation. And, and I'm thinking, okay, I don't know that I need that, but it's still cool. But I was very taken with some of the tips that you get through here. So, for example, he was printing support material for this wheel and then had it pause after the support material was down and took a permanent marker and drew over the support. And apparently that makes it much easier to release the finished part because the marker ink will dissolve with rubbing alcohol. So I was like, oh, I never thought of that, but what a great idea, right? There were a lot of other things in here like that, and just getting that kind of precision. And it's a beautiful looking project. I mean, if you look at the picture on the top of the article, I mean, it looks like something you would have bought. So I always like that too, that we're in this era where you can produce things that people can't tell are homemade. So it's a great article. I mean, again, it's not anything that I'm going to run out and build, and maybe you will, maybe you won't, but there's a lot to take away from it. And certainly next time I see a Kickstarter, I'll think, well, maybe I should just build it, save the risk.
I have to say, this is one of those things that you don't know you need it until you have it. A super scroll wheel for reading articles is so nice. And I read a million years ago on Hackaday, one of the old turn a VCR read head into a scroll wheel projects, which is a 2004 classic Hackaday project. I'll have to go find a link, the earliest link I can for that one. And I then took an old 5.25-inch hard drive apart. Well, I mean, we're taking hard drives apart in the hackerspace. And I was like, what can we do with this thing? And it's got a 3-phase motor in there. And you can actually read, because motors work like generators, you can actually read the little pulses off of the 3 phases of the motor. And I wrote a little bit of software and turned that thing into a scroll wheel and kept it on my desk for probably, 8 years, and used it to scroll through miles and miles of PDFs. And it's just, there's something that's fantastically nice about a huge inertia full stack of hard drive platters. And it just feels good to scroll with. But something that I noticed, and in common with Engineer Bose here, the hard drive platters and that VCR head and all have phenomenally good bearings in them because they're meant to spin at insane speeds for a long time. In this project, he just uses a regular old skate bearing, but even those are so high precision that he notices that if he puts it on an uneven surface, it just rotates downward all the time until the slightly heavier part is on the bottom. And strangely enough, he has to take the skate bearing apart and pack it full of silicone grease so that it's got a little more friction in it so that it doesn't rotate so freely. I think that's just sweet. That's one of those, when you've engineered the thing so well that it's so smooth that it's actually annoying that it's so smooth and you have to rough it up a little.
That's funny. Well, I have one of these Logitech MX mice, and I will say I appreciate the scroll wheel on it because you can, flip it. It can become the smooth kind of, not as high inertia as what you're talking about, but has some inertia to it. Or you can push a button and then it makes little detent clicks. And I got to take that apart one day and figure out how they've actually done that. Kind of the best of both worlds. You can scroll by the line, or you can just kind of go zing and swing all the way down to the bottom of that PDF like you're talking about. So
see, now you know you want it.
I don't know. Maybe I will. We'll see how the year goes. So far, the year is not providing me with enough time to build scroll wheels, but we'll see.
Here we go. VCR head jog wheel from 2010. Check that project out for a blast from the past. and inspiration for the future. Well, like I said, I was off at the 38th Chaos Communication Congress and seeing a bunch of interesting talks. This one I thought was neat and discussion worthy. The write-up of it is Taking Down the Power Grid Over Radio, and this is an investigation by two security researchers from Positive Security, Fabian Bräunlein and Lucas Maletti, and it is so cool. It starts off with kind of a stupid hacker gag. They see a box on a broken street lamp in Berlin and they look at it and it's got a radio and it's got a relay and it says on it that it's a Funkgrundsteuerempfänger, a radio-controlled power controller of some kind. And so they write down the company name and they look that up and they start doing their research. And it turns out that a lot of cities in Germany and actually kind of across Europe have these attached to streetlights, but other public infrastructure things to turn them on and off on schedule. And so, for instance, they wrote to a bunch of cities and said, you know, what kind of infrastructure do you have that works on these things after they found a security vulnerability with it? Ooh, foreshadowing. And a number of cities were like, yeah, our whole city light system works on that. In fact, we have one central street light that sends out a command to all the rest of them. And so they have one street light that has a light sensor in it. And if it's bright there, all the street lights are off. And if it's dark there, all the street lights are on. And I thought that was pretty awesome. The suggestion that you could find this one magic street light and go at it with a flashlight was pretty funny. But that's the kind of mischief that they had in mind here originally was, hey, you know, maybe we could turn off some of the lights in this neighborhood, turn them on in that neighborhood, make patterns that you could view from space or something in the streetlights of Berlin. And then they got to thinking about it and digging into where else this thing is used. And it turns out this system and similar are used for power load shedding and input power control. And so for things like solar power plants and wind power generations, they are also switched on and off the grid with this device. And that makes it not a toy anymore. In fact, it's a bit of important grid infrastructure. And so when they were poking at it and figured out its protocol and figured out how to turn these things on and off with a simple VLF radio transmitter, it started to get real. And so they did actually contact both the manufacturer and the government saying, hey, if there's all of this high reliability infrastructure on this, maybe you should consider encrypting it so that not just any old Yahoo like us can turn these on and off. And that's kind of the positive hacker story that comes out of this, is that they reach out to them. The manufacturer is like, oh yeah, we've been trying to push encryption for quite a while now. And the governments are like, yeah, we wanted to switch over infrastructure since 2017 and we've been working on it, but it's slow and we have to this and we have to that. And I don't know, there's going to be some social good out of having this hack there. And if there is, it maybe is going to be to push the regulators to get onto a newer protocol, a secure control protocol for these things. Because the other fun thing that Fabian and Luca do is they kind of ballpark estimate how much power is being controlled by these things. And it ends up being kind of 60 gigawatts, which conservatively, if you turned all the right things on and all the right things off at the right time across a country like Germany, would probably be enough to bring the whole grid down. And so that's like the nightmare scenario. To do this, of course, would take a concerted effort by like 1,000 radios, maybe more, scattered across the country. So it's not going to happen tomorrow. But it is one of those things that if you're responsible for public infrastructure, maybe you should clean up.
Yeah, the more you know about how things work at the low level like that, the more frightened you become, right? You don't really want to look into like how your power and your water and all these other things are done. But in all fairness to the cities, I knew somebody who had been a cybersecurity guy, and I always thought, that's the worst job, because it would be like if you had a fleet of cars and they said, now you have to loan these cars out to people to drive, but if anybody has an accident, you're fired, right? And
Right.
In his case, he had noted a remote access technique they were using that was not secure. Actually, there were two or three of them, and he wanted to close that one up. And they were like, oh, the customers won't like that. We can't do that. Well, a year later, a red team actually got in that way. So luckily, it wasn't a bad actor, but a red team got in. And then, of course, no one could remember that had been told that was not secure, right? And everybody was upset, and and of course, it got closed down immediately then, right? So unfortunately, you got to get the black eye before you will take stuff like this seriously. And until then, it's just, oh well, it's inconvenient. It costs a lot of money. I think this was great work by that team, and I was glad to see they were doing, I guess what amounts to responsible disclosure to it, and not just, you could have made a great Christmas display out of it. All of Berlin going synchronized to Jingle Bells or something, but that's probably not very responsible. So
The suggestion at the end of the talk is to play Pac-Man using the streetlights of Berlin and like dim them block by block as you eat the things. Yeah. Tons of good fun and jokes about this. But again, like you say, it sometimes it takes a very convincing argument or a black eye or whatever to make change speed up when it's being slowed down. And, if there's just a bunch of, I don't mean to be mean or overgeneralize, but bureaucratic inertia, sometimes it really just takes a convincing case like this to push things along faster. And I think that's the really good takeaway from this, is that they did their research into, exactly what is connected up using these boxes across the country. It turns out that a lot of the power plants, according to the rules, probably shouldn't be. The super big solar installations probably shouldn't be hooked up to these boxes after all. That's like an easy first step that the government regulators can take to addressing this problem. And they suggest that instead of, waiting for a general rollout, they kind of prioritize things by which are the biggest risks and handle those first. And convincing people that it actually is important work to put the effort into getting this stuff swapped out to a newer system is, that's really good work. And hopefully it'll get things changed sooner before, anyone decides to do anything dumb with the system.
Well, my next hack is from Andy. We've seen Andy before. Andy's building, I don't know if you're to believe Dan Maloney, he's building some kind of Terminator in the service of world domination, but I'm assuming that's tongue in cheek. But in this particular case, he does a lot with ball screws and ball nuts. And so we've had a couple of times that he's been in our pages for that. This time it's for a ball nut modification. And I thought what was interesting about that was really two different things. I mean, one is, sometimes you build stuff from scratch, sometimes you buy stuff, but it is nice now that we generally have enough things that you can say, oh, this is almost what I want. I'm going to get 90% there. And then instead of just giving up on the 10%, I'm going to do the other 10% myself. And that's kind of the story here. Keep in mind that other 10% was pretty extraordinary. These ball nuts, if you're not familiar with them, are generally, hardened steel. So actually going around and modifying them is not trivial. You can't get your Walmart electric drill out and put holes in them and things like that. It turns out there was an interesting trick there, is using an angle grinder on it was able to shorten it, but it also annealed the steel around the cut, which made it possible to put it in the lathe. And he's used that a couple of times. So a couple of little neat tricks in there, even if you think, well, I'm never going to actually do that if you're working with hardened steel. But I think what I thought was even more interesting about it was how over my lifetime, this has gone from being a very exotic, expensive technology to stuff that people use all the time. So think back, I mean, even in the early days of 3D printing, people were using like all thread as threaded rods for moving printer heads around, right? And it's like, that's terrible. The thread profile's bad, the precision's bad, they're generally not straight. People moved into lead screws, which are much better, especially if they're good quality. And then even then, ball screws were a little more exotic. And I put some links in that'll be in the show notes if you're not familiar with what all this means, or if you want to see some more posts. But Dan, a while back in his mechanism series, did a real interesting thing on lead screws and ball screws. But I think 3D printing has really made that more mainstream. Not that you 3D print any of this stuff, but because the printers tend to use them in the high-end CNCs and printers, And so I remember a time when I worked with a lot of mechanical engineers where they always thought it was funny that I was the electronics guy that knew what a ball screw was, right? Or a Belleville washer stacks and things like that. But nowadays, many people know about those things because we're building more mechanisms as a group. It used to be if you weren't into like robotics or, some kind of automation stuff, you didn't know what a ball screw was. You probably didn't know what a lead screw was. But now I think in our business, there's a lot more awareness of that. And then naturally, since we're hackers, that leads to people like Andy taking what's available and hacking on it. So good job, Andy. Again, you may not need this exact hack. It's not something like you're going to go, oh, good, that's exactly what I was looking for. But I think some of the techniques he uses would be a great benefit, not even just for ball nuts. So something interesting to look at.
It's funny you mentioned 3D printing because that's exactly how I got into any of this kind of CNC slash automation slash whatever stuff. And I can remember, like you say, back in the day when we used to use all thread for things. We used to use threaded rods to drive things. And of course, it's got horrible backlash. And so there were these funny contraptions with springs and two screws. So instead of riding on one screw on the thread, you'd ride on two screws with a spring in between them to kind of compensate out some of the backlash. And that actually worked really well. And then I remember when printers moved over to trapezoidal screws, and that made a huge difference. And yeah, I've got a CNC machine in the basement that has ball screws, and my God, that thing has no backlash. And so it's funny because like you say, all of my experience with this is not academic. I'm not a mechanical engineer. I'm just some dude who likes to build stuff. But these days, that means you have access to, it means you've gotten your hands dirty on a 3D printer or on a CNC router or whatever. And that's really...
Well, and there's mass market availability of these things at reasonable prices. I can remember buying ball screws, I don't know, several decades ago where it was a payment on a car.
Yeah, exactly.
Down payment on a house in some cases. Now, you go online and you buy some and they're not as cheap as all thread, but they're not so expensive that you think twice about it. So
Linear rails.
yeah, all that stuff. And think about all you know as a 3D printer enthusiast about like belt profiles and pulleys and all that. Who knew all that?
I remember when I didn't.
Yeah, I do too. There was that, especially that was all too low end for anything I ever worked on professionally. So when I got a printer, I'm like, oh, I see. There's these different types of belts. I didn't know any of that. So it's amazing how much mechanical engineering you just pick up as being a hardware hacker nowadays. And probably the converse is true, right? I'll bet there's a lot of mechanical engineers going, man, I never knew anything about microcontrollers and now I get an Arduino and I do. So they're probably laughing at us the way we laugh at them, right? But on the other hand, look at all we all are doing with all this modern stuff. It's great.
Hi, rounding it up from me is a science hack by Brian Hydet of the Alpha Phoenix YouTube channel. And this one is taking movies of light in flight. And I guess before he'd done some interesting things with, modeling how electricity flows in wires and trying to measure that in real physical setups. And this is then kind of the next logical step from there. The question is, can you take a movie in big scare quotes with a fast enough frame rate that you can catch light as it's moving across your room, and in particular across his garage? And the answer is no, you don't have anything with that kind of frame rate. I mean, light moves a foot in a nanosecond, basically, and you don't get that frame rate for anything less than, an MIT budget, as a bunch of people in the comments point out. This has been done before on the highfalutin science front, but the question is, can you do this on the cheap in your garage? And the answer is also yes, but it uses a trick. And the trick is that, of course, your oscilloscope is totally fine with measuring time delays on the kind of nanosecond range. You just, crank it all the way over and hit go. It's no problem. And so to discover when the light reaches a certain spot, he makes kind of a camera with a really thin field of view and connects it up to something that can detect tiny, tiny little bits of light and their changes very quickly. That is a photomultiplier tube. And so what he does is he essentially repeats the same experiment of turning the light on and saying, when does the light hit this point? And then he moves it over a little bit and he turns the light on and he says, when does it hit this point? And he turns it over again and he says, when does it hit this point? And so what he's doing is he's taking, I think, tens of thousands, if not more, of these kind of time series of light hitting the photomultiplier tube through this tiny field of view as he scans it across his garage. And then after the fact, he stitches them all back together into a movie. And it is awesome. You can actually see the beam of light flying across his garage and then bouncing off of the wall and then, back up and illuminating the ceiling. You can actually kind of watch it happen in super, super slow-mo. It's a fantastic effect. But it's not very hard. I mean, I lie. There are some really hard parts. And in fact, getting the super short laser burst is very difficult because you have to get a lot of current into the laser diode. And you have to do that quickly, and then you have to shut it off really quickly. So he's making these, super bright but super short pulses. He ends up using a photomultiplier tube because he wants to have a detector that also has a really short rise time so that he doesn't have to do any fancy DSP math to figure that out, right? It's much less blurry if you just have something that's on when it's on and off when it's off. I mean, those are fun technical hurdles, and I think it wasn't, an easy problem, but kind of conceptually, it's not hard to imagine how you could do it. And I think that's what's really cool about this too, is that he ends up with a real movie of light moving in his garage, only it's a composite over, 10,000 of these different turning on the light events.
Well, this actually reminded me of something, and maybe it's time to revisit it. But before I mention that, I wanted to let you know that I saw what you did there since you wrote this article where you said photomultiplier tubes are pretty damn cool. And of course, if you want low noise, you got to cool them with liquid nitrogen. So good job, Elliot. That was very subtle.
Unintentional, I swear.
Wanted to make sure everybody actually got your width there. So this reminded me of a system I worked on many years ago. We had a computer the size of like a giant deep freezer, like a big refrigerator. That was the computer for this thing. And we were firing electrons at microprocessors, and the secondary electron emission would either fly off energetically or not, based on whether or not what it hit was positive or negative potential, right? If it was negative, it would fly off like crazy. And if it was positive, it would kind of limp off. And so you could detect that. So if you did that for, like this, 10,000 times and averaged it out, you could say, oh, that spot that the beam's hitting is positive or negative. And if you rastered that across the chip and you did it at the exact same time through the thing that was running a program, right? So like you'd write a program and have an output statement and say, there's this pulse, delay 50 nanoseconds and take this measurement and then take it everywhere. And then you could build a picture of the chip where the positive parts were, black or white, whichever way you wanted to represent it, and the negative parts were the other color. And then if you started shifting that sample time in time, you could make a movie just like this. It was very hard to do at that time. But you could make a movie like this where you could like watch bits leave a register and go down a bus.
Right.
And then go into the other register. It was really the coolest thing I'd ever seen.
Oh, that's awesome.
But it also took this enormous processing power that now is like not even the display processor in my phone is as puny as that was probably, right? So maybe that's a good thing that we should be thinking about again. That's not that hard to do. Now, we had kind of scanning electron microscope material, but you really probably don't need that much. You just need some way to position the electron beam, some way to detect the secondary electron emission, and then precise timing, which is very much what he's got, right? Yeah. So this could almost do that. And it made me wonder, I wish somebody would take that challenge up. That was a cool piece of high tech back in 1983, I think, was the year we were doing that. And nowadays it would probably be a garage project, although probably like this, a garage project on a pretty significant scale, right? This isn't a weekend project for a beginner, but what a great job. I enjoyed watching those videos.
Yeah, and I love these kind of single pixel cameras, and we've seen a ton of those builds on Hackaday. I'll throw a link for a very recent one in there where you just kind of take two servo motors and, normal light dependent resistor and a tube, and you just kind of scan it slowly across the room and you can stitch together a picture. And of course you can do the opposite too. You can take a photoresistor and then you can light up certain spots and see what color they are. So you could like selectively illuminate different parts of the room and see what light reflects back to your wider angle light detected resistor. And it's kind of funny, all these different takes on, assembling pictures out of lots and lots of individual exposures. But then when I say this is actually how like old school tube video cameras used to work. The light from the scene hit the phosphor screen and you read by probing them with an electron across the thing. You raster across the screen and you would reassemble the image that way. Only you do it 60 times a second, which is fast enough to fool humans into thinking you're doing it continuously. But if you look at this in an oscilloscope, it's not even close to being continuous. So I just love this whole thing, because at once this seems like a crazy way to take a movie, but at the same time, it's also kind of vaguely related to the way video cameras actually do work.
Yeah, it's the electronic nip-cow disc, sort of.
Yeah, right?
I wondered why he needed to have the fast rise on the laser, because it shouldn't be that powerful of a laser, right? So you would have thought he could have used a CW laser and like an LCD shutter, which I think would have been a lot easier to get a fast rise, but maybe not. That's not my area of expertise. Maybe I'm out of my mind, but
How fast is an LCD shutter?
I don't know. That may not be true. It just seemed like, and you got to remember, what I know about lasers is all old tube laser stuff, so it seemed like it would be harder to start the laser than it would be to just stop the laser from shining through. But
Right.
I may be wrong. I don't know. I don't
think
know. It's
that's-
interesting.
yeah.
Maybe it's certainly something to look at. My last hack of the day is Teaching Tech, who's well known in the 3D printing community, but he's actually talking about a technology from the PolyDye project, and it's full color 3D printing with PolyDye and existing inkjet cartridges. This is a community-driven project called PolyDye. There's two people, Jacques and Bianca, that are behind it. I'm not sure how many other people are involved, but it looks like maybe a few. And it takes a really old idea and makes a really modern take on it. So you've probably seen, if you've browsed Thingiverse, there's some adapter that fits on your printer that you go put colored Sharpies in, and as the filament goes by, the Sharpie just imparts pigment in it, and now you've got your color printer. So you either can switch pins, or you could, have 3 or 4 pins and get different psychedelic colors, which is not always all that useful. This is a little different in that it marries an inkjet cartridge with dye with your printer head and then controls it so that it can color the filament as it's going in to whatever color it wants. What a great idea, and it seems like it should work really well. Obviously, if you look at their website or watch this video, it looks great. And I assume it really does look great, but I don't know. Naturally, I just upgraded all my printers to not use Marlin anymore. And this uses Marlin. So I don't know if I'm going to experiment with this yet or not. But, it's kind of an entertaining idea that they're taking off-the-shelf inkjet cartridges and have made like a holder for them. And then after that, I guess it's just software, right? You trigger the print head to blow ink out on the filament, and it's just kind of the same thing as the old Sharpie system.
Right.
I've always been super fascinated with doing color prints, and I've done them different ways. I actually have a, 4-head switching extruder that I have working, and it's such a hassle to set up, and it, produces all the waste material, that it's one of those things where I did it, I'm able to show people the picture of the things I made with it, and then I'm like, I'm done. I'm not doing that anymore. So something like this, where you could just kind of say, print me something in color, and it kind of pops out, no waste, presumably not much alignment problems, very attractive. They're in beta this month. They do have something you can buy, but apparently all the stuff is, on GitHub, and you could in fact do it yourself if you don't want to spend the money. I think that's a good approach, because it does look like it's not trivial to put all this stuff together. Plus, it seems like a great project to support. So
Yeah, and it's really neat because it's not much more complicated than driving a color printer cartridge. And that is actually something that we kind of know how to do. And if you want to see a talk on it, I'll point you back to a 2018 SuperCon talk. Sprite TM actually did a great one on, the magic paintbrush, which is basically him reverse engineering a color dot matrix printer head and figuring out how to make it print out whatever he wants it to. And that's basically the precursor to this. The rest is just realizing that squirting the ink in the right quantities at the right time on a piece of white filament is what you need to do. And that's really, like you said, that's another idea that's been in the tank for a while too. That's really cool. some of those old 3D printers that work with binder and they put down, grains and then over it with binder also did that. They ran over it with a color print head and would put color in it that way too. So it's not entirely a new idea, but this is by far the coolest and kind of most turnkey version of this I've seen yet.
Well, I wonder if you couldn't fill those cartridges with something other than color ink. Like if you could take one, that would cost you a color, obviously. But, we were just talking about using the magic marker as a release agent for support.
Ooh.
I mean, wouldn't that be cool if you printed your support and then your ink cartridge sprayed some kind of release over it so that when you printed, you'd have an easier time taking the support off? That would be kind of interesting as well.
My first quick hack this week comes from Guillermo Rausch. Protect your site with a Doom CAPTCHA. This one's just hilarious, but it's also a demonstration of how far we've come. This is Doom embedded in WebAssembly running in your browser, and you have to kill enough demons to prove that you're human. And actually, you can pick your difficulty level, and if you lose, it doesn't let you in, which I think is absolutely hilarious, but what is more human than the hubris to pick hurt me plenty and not get to your website? Next up, Florian Festi's long-running project, boxes.py, 2024 brought even more customization to boxes.py. He wrote up all of the contributions from the community to this long-running laser cutting box making program. And it's evolved to the point where the only thing that boxes.py has left anymore is that it makes easy finger joints. And then like all of these crazy projects, from wall hangers to soldering iron tip holders to et cetera, have been proposed for it. And what works for boxes is this kind of open, submit me a pull request of the cool box that you make and I'll incorporate it into the overall flow. And I think that culture is just a really neat open sourcey kind of hardware development mode. And I'm so glad to see it still working well. I've made a whole bunch of boxes using it. And last up, Kevin Dara, vPlayer put smart display in the palm of your hand. This is a sweet use of one of those little smartwatch displays. It turns it into a little standalone Wi-Fi accessible video display that's, 1.5 by 1.5 inches. You could put it on your desk and use it to display whatever the heck you want. I think that's really neat by itself, but the work put into making the screen work is also really cool. And if you need something like this in one of your projects, it's a good demo of how you could get that done.
Okay, my quick hacks. The first one's from the aptly titled How Not To, which was going to be my YouTube channel for doing stock picks, but it's already taken. So it's showing you how not to put saddles on a wire rope. And if you've done anything with an antenna, or if you're like, in my case, wiring power to code over to my shop, you don't want just a piece of Romex going across the gap there. So you have wire rope. And it amazes me how many times I see people put those little wire rope clamps on backwards. So I had not heard that phrase before, but it does help you remember. The phrase is never saddle a dead horse. And that has to do with the dead end of the rope versus the live end and where the little saddle on the connector goes. So check that out. Big Clive, no stranger to these pages, took apart a $5 emergency light and found out that it had a particularly clever circuit. It actually had a couple of little clever things to it, and it makes you wonder who's designing these things and how. Kind of think of it as being some institutional design factory just cranking stuff out, but it looks like this one might have had a little bit of a creative designer. Last but not least, Yu Yang had an academic paper on creating a mechanical qubit that lasts longer than what we think of as qubits. And qubits are, of course, vital to the quantum computers. And I really don't grok entirely how mechanical qubits would work, but I want to go dive into that paper, and I thought you might want to as well.
Well, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And this year, as every year, Tom Nardi wrote up 2024 as the hardware world turns, pointed his retrospective camera back at the past year to figure out what went on and what were the big interesting trends. And I think he came up with a good bunch of things that we saw a lot of on the pages of Hackaday. I'm interested to hear what you all think too. I think one of the major stories that he picks up this year in our space has been the desktop 3D printing reshuffling, he calls it. And this is kind of the poster child for this, I guess, is the Bamboo Labs printer. But a lot of other printers have been commoditized to the point where we have gotten to 3D printers that just work. And I think that's really awesome. I think the other part of the Bamboo Labs story is that they've brought multi-material printing into the mainstream. And we've seen much, much, much more of that this year. And I do think it's not just the bamboo printers. I think they're having kind of the knock-on effect that other people are making multi-material designs, and that's spreading all around. And 2 years ago now, I guess, Prusa came out with their tool-changing printer, which also lets you do multi-material, of course. That's their kind of high-end line, and it's very expensive, and I don't think it's made as much of an impact as the bamboo, which is a little bit cheaper than that. But it's neat to see what has been kind of a hacker slash fringy 3D printing thing that is doing multi-material prints come finally mainstream. I remember doing that way, way, way back in the day when we would edit our own G code and put pauses in there and swap out filament ourselves, which is essentially what these machines are doing. I mean, their multi-filament feeders are really just pulling the other filament out, pushing a new filament in and purging it out and then continuing the print. But the fact that it's doing it all so smoothly that you can execute these filament swaps multiple times per layer, and it doesn't take someone who's a dedicated 3D printing nerd to do it. I think that's pretty interesting. And I think that's something to watch out for in the future, is what's going to happen as more multi-material printing goes mainstream. One of the other things I think that's good to look out for in the future was Tom picks up that the CH32 family of super cheap RISC-V microcontrollers has kind of hit its stride this year. He mentions that we've seen 3 times the number of hacks using these chips this year as we did before, and a lot of them in the end of the year. So, the numbers seem to be going upward. And actually, we played around with them for the first time on our badge this year at the Super Conference badge and had a really great time. And that was in no small part due to Charles Lohr's CH32 Fun library. That is a really great way to get started if you're into straight up C programming, but they've been ported into the Arduino IDE as well. So if you're used to that tool chain, you're going to be set up. It's really interesting to see. And again, these are reasonably capable, super, super cheap microcontrollers. And a lot of that is due to them having the RISC-V architecture in them, which is simple and cheap to implement and has no licensing fees. 10 cents saved to the manufacturer on every chip that they don't have to pay to ARM or whatever. That number is totally made up, by the way. Don't buy or sell any stock based on this information. But I think it's really neat to see the RISC-V architecture finally kind of hitting its stride. And this is something we were looking at way back in, maybe 5 years ago when it was brand new, and saying, when is RISC-V going to take over? And it might be 2024 through these ultra cheap chips may actually have been the year that RISC-V hits mainstream in the hacker world. So we'll see what happens in 2025.
Yeah, Tom mentions the article where BitLooney clustered 256 of those chips
Right.
together. And I'm thinking, can you imagine doing that when you were paying, $9 a chip? That's a lot of money, right? And now it's $30, right?
Paying
So
$1 a
yeah.
chip, that's way too much money to do it for, essentially a shit post. But for 10 cents a piece, this is how BitLooney's project started off. I talked to him. He's like, man, they're so cheap. I'm going to put 16 of them on a board. And I don't know why. I don't know what I'm going to do with them. I'm going to have each one blink one LED. And then, of course, he scales it up and turns it into something cooler.
But I had noticed, too, the 3D printing stuff coming out. And you really, Bamboo just kind of soared into the public consciousness, if you will. And they really have popularized the color changer. But it makes me wonder, if you could fast forward 150 years ago from now, we both write a lot of historical stuff in Hackaday and other places. It's funny how many times you think like the incandescent light bulb piece I did, right? Oh, Edison invented the light bulb. No, not at all. There were dozens of people that did light bulbs. Edison just made the light bulb people wanted at a price they wanted and figured out how to tell them about it. So
Right.
those are the real elements there. So you wonder if in 150 years there'll be some historian going, yes, when Bamboo Labs invented the 3D printer or invented the
Oh
multicolor 3D
no.
printer, and we'll all be in the old folks home going, no, that wasn't how it was. We were doing that way before. Or, Arduino didn't invent C++ programming on ATmega processors either,
Right.
right? But they did it in such a way that people wanted it, and everybody else sold 50 of their kits that did that, including me, by the way, and Arduino sold 10 billion of them. So, yeah, but I'm not bitter. But so it just makes me wonder if that's going to be another case there where, all this has been brewing under the public perception for many, many years, and then Bamboo happens to put it where people see it, and they're going to get a lot of credit for that. And they should. I mean, like I say, clearly they've brought something to market that does what people want at the price they want and does it well enough that they're not angry about it. So good job. My can't miss for the day is Maya Posh's battery electric ships coming soon to a harbor near you. It just interests me because, obviously the world has decided for one way or another that we're going to put batteries in everything, right? Everything needs to run off electric batteries. And I don't know, I have mixed feelings about that. As long as you can show it's really better, that's great. But sometimes it's maybe questionable. And I don't really know enough about this to say, but I think Maya does a great job of putting up the data at least. Just to jump ahead to the conclusion, I mean, she even finishes off with practical within limits. It's clear that for shorter routes that use of battery electric propulsion can make sense. Historically, batteries are heavy, which is not always what you want on a shipping ship or, any kind of ship. They have to be removed and disposed of because they don't last forever. And in fact, maritime use has seen that for a long time, right? Because submarines had to have batteries because they don't really get enough air to run combustion engines underwater. And there's a lot of issues with that, right? It's not that they're just wonderful and they use them all the time. Anytime they can, they use the other engines and they use those engines to charge the batteries. So I don't know if this is really a thing or if it's just the current way of thinking. And, we're already starting to see a little bit of backlash against EV, not necessarily deadly backlash, but, everything goes from we're going to solve all problems for everybody to, well, perhaps we're not solving this problem and that problem, but we're still good for these other problems. And I can't help but wonder if this is a little bit more of the same. It's still very interesting. And I think as a design challenge, it's very interesting because you've got a lot of differences between batteries and fuel, right? Gasoline, I can stick in tanks with weird shapes. It's very easy for me to get gasoline or diesel or marine gas or whatever you want to call it. It's a little harder for me to find battery chargers. And in particular, you wonder if you were to take it for the longer routes, you get into the problem that airplanes have had for years is, well, your power plug doesn't fit my power plug. So I want to charge, but we see that with like the international docking standard for spaceships too. It's like, well, we've got the plugs that are the same, but how much power can I draw from you? Well, last time I checked, the standard doesn't tell me. So the idea that you can just do like on Star Trek or Star Wars and just dock with the other ship and everything works, we're not there. You've got to make a call and say, that power pin, are you pushing power or are you taking power from me? How much are you taking? How much are you giving to me? A lot of other little things like that. And I think as you start trying to electrify things that cross borders like this, you're going to have similar problems, short of world standards. So it's going to be interesting to watch. It's another case of where we're seeing the electrification of some other transportation mechanism, and I'm curious to see how it's going to turn out.
You mentioned the standards thing. I think this is one of the things that the international shipping community has down. And like, if you look at those container ships, well, I mean, they're container ships, right? They hold these absolutely standardized containers, and they are all the same size because that's the size they have to be to fit through the Panama Canal. And they roll into harbor, and they're so regular that a robot can unload them, right? And I wouldn't be surprised if the same sort of infrastructure could be developed for putting batteries on and off of ships, right? Like, there's no... You worry about the amount of time it has to take in dock to turn over. But if you could just fill up a bunch of containers with batteries and make kind of a battery, a replaceable battery for giant cargo ships, maybe that could work. But like you say,
Yeah.
I do think there's a hard limit to this, and Maya brings this up in all these academic papers she cites, and that is that, when the battery starts taking up a third of the cargo space, you're going too far. And so it really is only reasonable for kind of these shorter hauls and, high intensity things. She mentions tugboats. Electric tugboats are kind of already a thing, and that's because they do lots of short runs where they need to put out a lot of grunt, and that is a reasonable case for it. But like when the battery starts competing with the containers for space inside the ship, and it's the containers that make them the money, I could see how the economics works against the battery there.
Yeah, and of course, ISO 668, I happen to know that is the standard for intermodal containers, but I think that I don't know. That'd be an interesting Hackaday article, by the way, is, maybe as a tech in plain sight, is how hard was it to get to that standard?
Right.
And I don't know the answer to that. I don't think it was just somebody woke up and wrote the document. I think it was probably a long process. And of course, there's not just one size of 688 container, right? There's like, I don't know, there's like 12 of them, but there's only 12 of them or however many there are. I don't know how many there are, but there's a certain number of them depending on what you want to do. And there's a 5-foot and a 45-foot and a 30-foot. There's a very weird and uninteresting reason why I know these things. I don't think it was just by fiat, and I suspect it would be much the same. So just like one day, the space community will have a docking standard where the Klingons can just come dock and they get their power and they get the oxygen and they get everything else. But today they got to call ahead and make sure, even though you can mate, doesn't necessarily mean you're doing the right things. And I imagine this industry would be the same way as, I've got a plug that fits you, but by the way, do you realize I've got 300 hertz, 240 volts coming through and you're expecting different? We have to talk about that first. So, and eventually they'll get there too if it turns out to be important enough. Just like we got USB chargers on everything now, right?
Probably going to happen exactly the way USB-C turned into the phone charger. It seemed reasonable, and then they decided to codify it. And I bet you a container full of 18650s is going to sound reasonable in the future.
until it burns up, but yes.
You don't want to short circuit that one, huh? That's all the time we have for this episode. Thanks tons for listening. If you have a hack you'd like to send us, shoot it over to tips@hackaday.com. And you'll find all our links over at hackaday.com/podcast. So happy New Year. And until next week,
keep those hacks coming.
Sounds good to me. Where's the thing where I can tell it to not do? They've moved my cheese. Why have they moved my cheese? Oh, dude. Okay. Yeah, let's do it. Protecting. All right. I think we're set. Lovely.